In this video, you will learn to memorize, identify, and use properties of addition and multiplication. The first property we're going to look at is both for addition and multiplication, and that is our commutative property. Now the word commute in English, commute, C-O-M-M-U-T-E, in English means to travel or to move. So you would say that an individual would commute to work, meaning they drive or travel to work. So the commutative property has the idea of moving. So what is moving is going to be the numbers. So this property says that when we're adding, it does not matter in which order we are adding the numbers. So we can move the numbers and still have the same answer when you're adding. So using letters and math notation, we would say that A plus B equals B plus A. Meaning, doesn't matter if A comes first or B comes first. We can move the numbers around and still get the same answer. With actual numbers, we can say 4 plus 5 equals 5 plus 4. That is a true statement because the order of the numbers does not matter when you are adding. So we can move the numbers around or commute the numbers and still have the same answer. Now the commutative property also is true for multiplication. So for multiplication, we would say that it does not matter in which order the numbers are being multiplied. So in math notation, if we just use letters to represent numbers, we can say A times B equals B times A. Doesn't matter if A comes first or B comes first. Using actual numbers, we can say that 4 times 5 equals 5 times 4. It does not matter how we move the numbers around with multiplication. We still get the same solution. The second property is called the associative property. And this, again, will hold true for both addition and for multiplication. So the word associate, you see the root word associate, that word in English means to be a part of or to be with a group. So for example, you might associate with a certain group of people. It means you're part of that group. You associate with them. So this property in math has the idea of grouping. Okay, what groups go together? So a simple explanation says that when you're adding 3 or more numbers together, it does not matter which numbers are grouped together and added first. So looking at letters, so using just letters to represent numbers, notice we have 3 numbers or 3 letters added together, A plus B plus C. It does not matter if we group together A plus B and add those first, or group together B plus C and add those first. So using actual numbers, if we had 4 plus 5 plus 6, it doesn't matter if we group together 4 and 5 and add those first to get 9 plus 6, or if we group together the 5 and the 6 to get 11, and then we add 4 with that. Either way, we get 15, right? So it doesn't matter how we group together the numbers. Okay, we still get the same solution. So the grouping does not make a difference with addition. And same thing for multiplication. When you're multiplying 3 or more numbers, it does not matter which numbers we multiply first, and to do that we kind of group together the different numbers. So using letters and math notation, we would say if we have A times B times C, it doesn't matter if we put A and B first and multiply those together first, or if we group together the B and C and multiply those together first. So looking at actual numbers, if we had 2 times 3 times 4, it does not matter if we group together the 2 and the 3 and multiply those first to get 6 and then times 4, or if you multiply the 3 and 4 together first to get 12 and then multiply by the 2 after that. Either way, we still get 24 as our answer. So again, the associative property has the idea of associating or grouping the numbers together differently. So it's saying the grouping can change. Next we have what is called the identity property. And again, with this property, we have both for addition and for multiplication. Now, in English, we might say that an individual might change his or her identity. What they're doing is they're changing the way they look, right? So the identity property has the idea of something that can be added to any number without changing the identity, without changing the value, without changing the way it looks. So if you think with addition, what number would that be? What number do we add that does not change the identity or the value of a given number? Well, that number is going to be 0, right? Because anything plus 0 does not change the identity or the value of the original number. So the identity property basically just says that this number 0 exists. So basically anything plus 0 is going to be itself. It's not going to change the identity. So we would say that 0 is called the additive identity because we also have one for multiplication. So in math notation, we would say that a plus 0 or 0 plus a would equal a. It doesn't change what we started with. We start with a, we add 0, we still have a as our answer. So with actual numbers, we can maybe say that 9 plus 0 would still equal 9. We started with 9, we add 0, we still have 9 as our answer. The identity or the value of 9 did not change when we added the 0. With multiplication, we also have some number that does not change the identity when we multiply. And that number for multiplication is going to be the number 1. Okay, the number 1 would therefore be called the multiplicative identity because that is the number we multiply by any number that does not change the original value. So in math notation, we would say that a times 1 or 1 times a would still equal a. We start with a, multiply by 1, we still have a as our answer. With actual numbers, we could say that 6 times 1 would equal 6. We started with 6, multiply by 1, which did not change the identity. We still have 6 as our answer. So that is our identity property. Next, we have a property that only is true for multiplication, and that is what is called the 0 property. So the 0 property of multiplication says that anything multiplied by 0 will equal 0. So in math notation, we can say that a times 0 would equal 0. Doesn't matter what a is, it could be any number, multiply it by 0, and 0 would be our answer. So with actual numbers, we can say that 4 times 0 equals 0. Okay, anything times 0 is 0, and that is your 0 property of multiplication. All right, next we have what is called the distributive property. And this one you've hopefully been exposed to before, but we'll go through it again here. And this property says, it's actually hard to explain in words, but we'll give it a try here. It says that to multiply a sum by a factor. So if you have a sum multiplied by a factor, each addend, so each number that you're adding, is multiplied by this factor, and then the resulting products are added together. In words, this is kind of difficult to explain, but using an actual example, it makes, in my opinion, much more sense. So in math notation, we would say that if we had a, some number outside, being multiplied by b plus c, two other numbers, what we can do is we can distribute or multiply the number out front with both the b and the c. So we have a times b plus, and then a times c. Okay, this still might be confusing with the letters, so let's take a look at an actual example with real numbers. So let's say we had 5 times 4 plus 1/5. So this is our example. What we can say is that we can distribute, or think of sharing. Okay, if you distribute something, we're sharing with more than one thing. So we're sharing this 5 with the 4, so 5 times 4. and sharing the 5 with the 1/5. So 5 times 1/5. And then whatever sign is here in the middle, we put that sign right here. That's a plus sign. So the distributive property says we can distribute the factor in front to both addends, both numbers inside parentheses, and then the resulting products are added together at the end. So those are all the properties we're going to discuss in this lesson. And what I have next are 2 slides that show you a summary of all the addition properties and a summary of all the multiplication properties. I'm not going to go through those because we already did that, but I'll show it here for a moment. If you want to pause the video, you can take a look. So addition has a commutative, associative, and identity properties. And then multiplication, here is the summary of the multiplication properties. We have commutative, associative, identity, 0, that's unique for just multiplication. And distributive, we put here in the multiplication property because you're multiplying the factor with both terms in the parentheses. All right, so this is a summary of multiplication properties. Now to finish off, we're going to give you some examples where you can get a little practice with identifying which property is which. All right, so try to answer these before I give you the answer. Here are your options. Okay, so using these as our options, our first example, we have 8 plus 6 plus 5 equals 6 plus 8 plus 5. Now this one, just be careful because the temptation is you see parentheses and you might just automatically assume, oh, that's going to be associative because associative has to do with parentheses. Well, that is true, but that's really not the property we have here, because if you look at the parentheses, the grouping is not changing, right? In the first parentheses, we have 8 plus 6. Second parentheses, we still have an 8 and a 6. So the grouping is not changing. What is changing is the order of the addition. We're moving the numbers around. So the movement of the numbers, that is your commutative property. That'd be option number 2. So any movement of the numbers like that is commutative property. Okay, here's another example. We have 8 plus 6 plus 5 equals 8 plus 6 plus 5. This one, notice what is changing, and that is what is in the parentheses. Here we have an 8 and a 6 in parentheses. Here we have a 6 and a 5 in parentheses. So what is changing is the grouping. So this one would be your associative property. That's option number 1. Here's another example. 0 plus 8 equals 8. Okay, this one would be your identity property, because notice that we had an 8 and we're adding 0, which does not change the identity of the number. We still have 8 as our answer. So it does not change the identity when we add the number 0, so that is our identity property. Next one, we have 5 times 0 equals 0. This one is number 5, our 0 property, because that property says anything times 0 will equal 0. Next one, we have 8 times 4 plus 1/2 equals 8 times 4 plus 8 times 1/2. This one would be our distributive property. So we do 8 times 4, that's what we have right here, plus 8 times 1/2, which is what we have right here. We are sharing or distributing the 8 to both terms, so that is our distributive property. Here is another example. We have 4 times 3 times 2 equals 4 times 3 times 2. What is changing here is the numbers in the parentheses. So right here the grouping is changing. We had 4 and 3 together. Here we have a 3 and 2 together. Because the grouping is changing, that is option 2, our option 1, associative property. So associative property has to do with the grouping. Here's another example. 5 times 4 equals 4 times 5. This one, what's changing is the order of the numbers. The numbers are moving, so that is commutative property. The word commute has to do with moving. One more example. We have 5 times 1 equals 5. This one, notice we started with a number. We're multiplying by 1, and the identity or the value of the number is not changing. We still have 5 as our answer. So that is option 4, our identity property. And that concludes our lesson for today. We will see you next time.